So, did y'all have a good weekend?
Yep.
Just kind of good. So tomorrow's gonna be a nuts day, huh? Well, you know, we have big election. All of the stuff we've been getting, the phone calls, the emails, the snail mails, people stopping as you go into the mall.
Do we have assembly on Friday?
I don't know. I don't think so. So it all comes down, you know. We either have, and I'll tell you what, the stock market right now is going absolutely nuts. It's going through the roof right now. It was like 360 points up right now.
Wait, I heard something like the green Starbucks cups being because their stock went down.
Starbucks green cups.
Yeah, they're supposed to be red, but then they made it green this year, and everybody's freaking out.
Yeah,
So you're just touching my paper.
The Starbucks
I don't know what the big deal about Starbucks is, man. I tell you what, I like strong black coffee, and I hate Starbucks coffee.
I've never drank coffee. I hate coffee.
But y'all seem to like the pure syrup that you get. The sugar and syrup, huh?
Hey, Sawyer, when I say Bernie,
All right.
Say it.
Bernie,
Come back.
Bernie, Bernie.
All right. So we have a couple kids on task. Shh. We have already learned side, side, side. Correct? So side, side, side was if I have three sides of one triangle congruent to three sides of another triangle, then the two triangles are congruent. You couldn't have just a single side to make, because you can make two completely different triangles. You couldn't have two sides. You had to have all three sides. But now we're going to say that we can do this with side angle side, so SAS, and hypotenuse leg. Yeah. Sure.
Okay. Why was the student's report card wet?
Why?
Because his grades were below sea level.
Oh.
Stupid.
Okay, can I just one more?
Okay.
Why was the tomato blushing?
Don't know.
It saw the salad dressing.
Oh, wow, this is great.
Hopefully that's the last of them. All right. So if I'm using something called the hypotenuse leg, what kind of triangle are we thinking about if you have a hypotenuse leg? Yeah, right angle. So if you have a hypotenuse leg, that means that you have a right angle in there, but hypotenuse leg will prove, of one right triangle will prove that the hypotenuse leg to another triangle makes both triangles congruent with right triangles. If we have two normal triangles that don't have to be right triangles, we have a side, an angle, and a side of one. And you notice how it says SAS in that order. If I have ASS, that's a bad word. We can't say that in class. So.
Oh my god.
But angle side side actually creates two different triangles. But if you have a side and then the angle that is in between the two sides, so the included angle, meaning if I have a side to side and you have the included angle in the middle, if those are congruent to another triangle, it's going to work. So, how many pairs of corresponding sides must be congruent for two triangles to be proven congruent? How many pairs of congruent sides? Well, we have to have how many pairs of corresponding sides? Corresponding sides must be congruent for two triangles to be proven. You have to have side, side, side. You can't have anything less than, unless it's a right triangle. So, can we prove two triangles congruent using only angles? Well, let's do this. Let's go straight edge. Edit. Copy. Paste. Oh shoot, I wanted to increase the size of it. Nope. Let's undo these. So undo. And let's do a shape. Okay, so I have this triangle, and I highlight it, and copy and paste it. Okay, I'm going to maintain the size of the angles. Are these triangles congruent?
No.
Yes or no?
No.
No. Okay, so if you maintain the angle but not the size, you have a scale value that you're able to do it. This does not prove they're congruent. Remember, congruent means all three angles, all three sides are congruent, nothing else. You all right back there, sunshine?
I need to sneeze.
I'll wait.
No, I'm good. I'm good. I'm just gonna like hold it in and then just roll through my face. It's no good. Alright, Sawyer, okay, you know what? Do it.
Yeah, I know. She told me.
Ready.
We just did that, so we don't have to be cutesy. Okay, so we can't use, so angle, angle, angle will not prove congruent. So it proves something called similar, which means we maintain the angle size, but we can't say it's congruent. We can't say the sides also. We need to experiment with two sides and an angle. So if I had if we had a side and angle and a side, and if I generated this a second time, but I really don't have to, this is the only triangle that can be drawn if I did that. And how you can prove something like this is you could take your geometry tools. Haven't seen this in a while. Welcome back. So let's open her up. Okay, so I have that. I'll draw another line segment up here. Obviously much longer. I'm going to put a point on there. This point and this point we'll call A. Call it A prime just because we're going to go there. I'm going to maintain the size of this angle. So I'm going to bring my Jim Dandy over here, put it here. And let's draw our angle. Come on, baby. Okay, so I've measured that. Move this out of the way. Let's duplicate this angle. So I've measured this distance here. So this distance is here. Now I have to figure out what this angle is. So I'm going to measure from here. So we'll call this, say, X. And we'll call this Y. We haven't generated X and Y there yet. Actually, X would be right here. So let's generate Y. So anyone remember how to use the protractor or the compass to duplicate the angle? Okay. So you put both ends on each point, here and here. Measure the distance from those points. That looks about correct. Move it over here. Let's flip it over. Flip it over. Put it right there. And let's swing an arc. If I connect from here to here, I've now duplicated my angle. So using a straight edge, just come straight through and draw that. How would I measure the distance from that? Let's call that A to B, and let's call that C. How would I figure out where point B is on this line as far as duplicating the segment? Yeah, use the compass. So bring the compass. Put the point here. Open it up to the distance. So if I take this point and I move this over here, onto here, and swing an arc, this distance here is segment AB. Okay? If I do the same thing here, if I measure from here to here using the compass, duplicate this here. This now becomes point C. So I have a side, an angle, and a side. Now if I connect points B and C together, this angle, this angle, this angle, this angle are congruent. This side is congruent to that side. And so that proves that side angle side will work. If you say side angle side, you have to remember you're including the center angle between those two sides, the one that's where the vertices is coming about. So side, side, side will work. If I did one later, let's just do this. Is that a blank? Okay. So side angle side we've proven works. Okay, which means you have a side, the given angle, and that. Does this work? Does this work?
No.
Yeah, I have ass on the board. Okay, I'm going to show you why this doesn't work. Okay, this says I have an angle, and then I'll draw a side and a side in that order. Agreed?
Yeah.
Everyone with me on that?
Yeah.
Okay, so let me just create an angle. So this is the angle we'll use, and then I'm going to use this segment and this segment in order to generate the rest of it. Okay, so when I generate my angle, this side, one of the sides is kind of a fictitious side. Okay, so if I duplicated this angle, now I'm just going to make it like this, rather than using the compass. Copy, paste. Agree, same angle? Okay, so what I'm going to do though, is I'm going to make this kind of a dotted side, meaning it doesn't really exist as far as our shape goes. Agree? And I could use my compass, figure out this length. So let's duplicate. So I'm going to extend this here. So from here to here is this. Agree? So if I come over here and I duplicate this one, doing the same thing. So this means from here, I'm going to swing a big old length. So from here to any one of these directions, and to maintain this angle here, we're going to get two different triangles that are possibly going to take place. So I have this segment here, that's a constant. I have this angle that's here, that's a constant. So B and I was able to do this. If I were to take this arc and continue it, notice it's crossing here. So I can create this segment here. But then I can also take this segment here and draw here. And it's going to create two different triangles. Actually, I was off a smidge on that. But angle side side, there's something. Do you know the sine button on your calculator, SIN?
Yeah.
Sine is the opposite over the hypotenuse as far as trigonometry goes. But then you use something called law of sines, which means you take the sine of an angle over its opposite side is equal to the sine of an angle over its opposite side. And you have something that's called the ambiguous case, meaning there's two triangles that can be drawn, and that shows why the angle side side won't work. I actually think I should have drawn this one first and then swung the bigger arc, and it would have worked out a lot better for us. But that's the ambiguous case why angle side side won't work. Now consider the angles below. So I have a side, an angle, and a side. This is the included angle between these two sides. This is a side, an angle, and a side. Here's the angle in between these two sides that are congruent. Here is a side, an angle, and a side where this angle is in between these two sides. And the last one, we have a side, an angle, and a side. So this shows us on each of these that side, angle, side does indeed work. Make sure you have the angle in between the two. Okay? So talk about it as you're going around it. I have a side, an angle, and a side. I have a side, an angle, and a side. I have a side, an angle, and a side. I have a side, an angle, and a side. You're going around the triangle to make it work. Making sense? And again, side, angle, side will prove two triangles are congruent. We already said side, side, side will. Okay? Another new postulate, if two sides and the blank angle of one triangle are blank to the two corresponding sides of another, I don't know, let's see what they got here. Just the arrow, that's it? Let's see what's more. If two sides and the included angle of one triangle are congruent to the two corresponding sides and the included angle of a second triangle, then the two triangles are congruent. And that again is side, angle, side. Okay, so again, if you had a side and you had an angle you knew and another side, that's all you need to prove that when I connect the dots, when I look at those angles, everything else is going to be congruent. Okay, so to prove the two triangles are the same or equal to each other. What are some ways that to prove that sides are congruent? Measure them. The compass works. Okay, what are some ways that we can prove angles are congruent? Duplicate the angle. Okay, the compass works. I know we haven't been using the compass a whole lot. In fact, it's been probably 8 weeks since we've used it, maybe even longer. But the tools of geometry will indeed work. Okay, the pointy end to the pencil end is a length. It's a constant length. How long is it? Well, the compass doesn't necessarily tell you the length of it. It just says this is the same length as something else. And then by duplicating angles, you can prove that the angles are congruent to each other as well. All right, proof time. Okay, so I think a lot of you did really well on the proofs. A couple things that I saw that I want to make sure I go back and make sure we cover. And let's just make sure I write the whole thing. Now, you guys did great with the givens. Everyone got all the points for the givens. I want to congratulate you on that. Okay? I didn't have anybody that left them blank, so there was some that all the points they got was the given, but better than nothing. Okay, so we know that MP and NP. MP, so it's marked. We have the marks. We know they're congruent. And then they tell us that segment OP bisects the angle. If it bisects the angle, what does that mean? The angles are congruent. So we're looking at this angle here being congruent to this angle here, but we can't just say, oh, that's good. We have to tell them that, and here we can't say just angle O is congruent to angle O because you have to decipher the direction. So I can say that angle MOP is congruent to triangle NOP. Mop and Nop, they're brothers.
Wait, that's the wrong angle that you put it. It's angle MTN that it bisects, not MON.
You are oh man, I love it.
Right?
I love it when people pay attention.
Kids.
Ah!
Ow!
I had the wrong angles. Man, you guys rock when you pay attention in here. I'll tell you. Favorite class. All right, so they tell us it cuts this angle in half, so we have this angle here and this angle here. I'm sorry. You know, I was cutting a limb off the tree this weekend. I was kind of high up. I fell. I wasn't kind of high. I said I was kind of high up. Jeez. Can't go anywhere with you guys. Angle MP. I'm kind of high. Jeez. MPO. And then angle NPO. Okay, now we're good. So we know, but why can we say this? What took place? It's not reflexive. It's the definition of bisect. Then we can say our reflexive property. We can say that this is congruent to itself. Yes, it's the redundant property, but we have to say PO is congruent to PO, and that's a reflexive. And then, and a lot of you got reflexive right. There's a couple people that didn't, you forgot to put it. And I'm like, dude. So I have a side and angle and a side of one triangle congruent to a side and angle and a side to another triangle. So I can go ahead and say that this is congruent to this. And that is because we have side, angle, side. We have a little sass. Yo.
So that eliminates, you don't have to find the values of MO and ON.
You can already justify that both those triangles are congruent to each other. Sweet. Let's try another and move on. Ooh, it's a circle. What do we know about a circle?
Radii ideas.
You got some radii. So the only thing that's given up here, is we have circle M. One given, man, I only get 2 points on this problem. If that's all you want to put, that stinks. Yep.
What if, like, the given is, like, 3 steps, but you put it all as one?
That's fine.
Okay.
I was able to understand it. Because you put commas, I was like, dude, I'm with you. Yeah. So, could I state this is congruent to this?
Yes.
Why?
Definition of radii.
I'll take it.
Good job, Ben.
F of radii. Then I could easily say that this is congruent to this. And that would be PM. So SM is congruent to MQ. That's another radii. 3. I love it. All right. I want to somehow try and figure out if I have an included angle between here.
Oh, I know. Hey, Casey. Or Molly too. They both got it. But
Casey, what do you got?
Hi, how are you?
I said angle SMR is congruent to angle PMQ.
All right, let's see. Angle SMR is congruent to angle what? QMP?
Yeah, whatever.
Okay. I'm just trying to keep the letters in order. It's a vertical angle, right? So we have vertical angles here. So this angle here is congruent to this angle here. So now, do I have a side angle side of one triangle congruent to the side angle side of another triangle? The answer is yes. SMR. So this triangle are both congruent to each other because we have R is congruent to triangle QMP because we have side and an angle on the sides. That's it. Yeah.
What's the term for like the line, like for example, like SR? Like that isn't there? I thought there was a term for that.
This is a chord.
Yeah, that's what it was.
Those are both chords, absolutely.
Okay.
We don't necessarily have to do that. Where this problem could get to is they could ask you on this kind of problem, and this is like a couple days away, but they could have asked, prove this is congruent to this. And so what you could do is once you've proven the triangles are congruent, once you've proven this, then your sixth step is saying this, and it's actually called CPCTC, which is corresponding parts of congruent triangles are congruent. But don't worry, you can write the whole thing out. Yeah.
Ow.
We're not there yet. So this is coming up in a while. This is not today, it's later. So Sawyer's scared. It happens. He's still sick. He has a fever. His mom decided to send him to school anyhow.
Wow.
Can we use two sides and an angle that is not included to prove congruent? We're not going to do this. We're not cutesy. So, they say SSA, I say ASS. I mean, come on, they're the same thing, right? One's reflexive to the other. It's more fun to say bad words in class. That way you can say, yeah, we're cussing today. Okay. I mean, next thing we're going to do is we're going to say the F word. We're going to say fraction, and it's really going to go crazy in here. Okay. SSA will not prove congruence. If you spell it the other way, you will be reminded it does not work. Okay, great. All right. Sorry. I don't write these slides, I just teach them. All right, what are the terms? What are the terms for sides of a right triangle? So, hypotenuse,
Do you have to write leg 1 and leg 2?
leg, hypotenuse, leg. Do you have to do leg 1, leg 2? I don't know. I know what you're talking about. All right, so hypotenuse leg. Okay, you have that 90-degree angle, which means something. This is where a lot of your trigonometry will start working with right triangles. You have two acute angles, so acute and acute, if you wanted to put that in there. And it's on the other one as well. Okay, so that's about all you could say about these. We start using Greek letters when we refer to the angle, so we'll say theta and things like that, just because the Greeks seem to know best. So, what do we know about the sides of a right triangles? Well, if I go 3 squared plus 4 squared, I get question mark squared, which is this, which is this, which is 5, right? And so then if I did this, it's the same thing. I could go question mark squared plus 3 squared equals 5 squared. Question mark squared plus 9 equals 25. Question mark squared equals 16. Question mark is equal to plus or minus 4. We're talking about a length, so it's got to just be 4. Okay, so that's the old 3, 4, 5 right triangle. That's kind of one of the Pythagorean triples. What do you know about the sides of right triangles? We know it. We know that the sum of the squares of the legs is equal to the hypotenuse squared. It's called the Pythagorean theorem. Developed in the 6th century BC or BCE, depending upon your religious preference. So, That's about it. You know, Pythagoras and Isosceles were good friends. Isosceles, come here. Yes, Pythagoras. Sorry, that's all my acting. If we know the lengths of two sides of a right triangle, then we can always find the length of the third side. Yes, we can do that. We can do that because Pythagorean theorem works. What does this mean in terms of proving right triangles are congruent? I don't know. They're going to tell us. If the two legs and hypotenuse, or wait, no, maybe this is hypotenuse and leg of one right triangle are congruent to the hypotenuse and the leg of a second triangle, then the triangles are congruent. So this is why the hypotenuse leg works, because the Pythagorean theorem works. Hypotenuse leg, if you have the hypotenuse and one of the legs of one triangle congruent to the hypotenuse and the leg of another right triangle, then the two right triangles have to be congruent to each other. Moving on. Ooh, proof time. Okay. So, we know that
I'm sorry, it was a Harvard there.
What the hell's wrong with you?
This is why God doesn't talk.
Did a young man bump his head or something?
If you did that in any class but yours,
All right. So now we're all done with all of the shenanigans, huh? All right. What does the upside down T mean? Perpendicular. Okay. So they tell us this is perpendicular to this. They tell us this is perpendicular. These are congruent, which is marked. We probably should state this.
That they're 90 degrees.
Yeah. Why could I say that?
Definition of perpendicular.
Yep. All right. So then we know that and that are good. So now we've established we have a right triangle. So our hypotenuse is the same. Oh, we could say this. Why? Huh? Reflexive. Can I prove the triangles are congruent?
Yes.
Yeah, I can easily say XYW is congruent to triangle ZYW. Not because of SAS. Hypotenuse leg. The hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg of the second triangle. Is that it? You kidding me? That's it? Questions? All right.
Oh, sorry. Can you go back?
Sure. Probably not Thanksgiving. I'd like to go longer without. Your guys' grades are better when you go long. All right, we good? All right, so have we figured out what Don's problem is?